engineer, and I'm come from Nanjing. Yeah. Today, my topic is the XenServer power saving. And in this topic, I will mainly talk about three things. First thing is what we already do to save the power in the server. And second, what the problem maybe have in the currently power saving solution. And the third, that is my power saving initiative. So we will take a look at these major points one by one. First, what we already do to save the power. Like the reduce, reuse, and recycling. Since XenServer is a virtualization platform, it's designed for reuse all the resources in the computer system. So we really do a lot to reuse the information. And the slogan, reuse is reduce. So we also reduce a lot of the hardware and power usage in the system. And to even do better, the system have the ability to sleep, to hibernate, or to stand by of the system, so we can save a lot of power. Think about the working load balance of the XenServer. Working load balance has the ability to migrate the VM to a specific host. So when the working load of the whole system is low, we can migrate all the VMs to a specific host. Then we can shut down all the other hosts that with no VM running. That is another kind of resource reduce in the XenServer. And also for recycling, working load balance has the ability to migrate VM from host to host, so it can balance the I/O, the bandwidth of the network, and even the CPU usage or the memory usage in the server. So yeah, we really do a lot of things to reuse and reduce and recycling the power in the XenServer. But sometimes, despite of the technology, we still have problems. Like this picture. I want to ask how many of you are choosing to shut down your computer after use. To be honest, for me, I will never choose to shut down my computer. Why? Because it will take a long time for me to wait until the system to boot up, right? And sometimes I will still need some information to keep in my computer. I want to use it the next time. So almost I will not choose to shut down my computer. And that will make my computer as an idle computer in the system, which will also idle VM in the whole XenServer. And sometimes we will also complain about that we don't have sufficient resource to use in the server. The most complaint was come from sometimes like we don't have sufficient resource because the resource is allocated to the idle VM. That idle VM was doing nothing but consuming a lot of resources. So I think that is the problem or the pain point of currently power saving solutions. So can we do even better? Yeah. Like this, if we do these things like this robot or something, we can plug it myself and unplug it myself. If we don't want to use, I think most of the problem can be solved. We can resolve the problem by unplugging it ourselves when the VM is idle. And when we require the VM to use, we can plug ourselves in. Then we can solve the problem. Yeah. So can we do the same thing in XenServer to have the power manager for the VM? I think the answer should be yes, since we have a working load balance to manage the VM. So we can even suspend the VM, or stop the VM, or start the VM by command. So it really can be done in the XenServer, but how? To resolve the problem, how we can have the solution, we need to first define three main points of the solution to deploy. First, what we need to do is to say what is target we want to have. And second, what is the condition to deploy the power saving policy. And the third, that is the action we need to do to save the power. And I will talk about these three topics one by one. And first, I want to say the target here, because we are using the XenServer. So the target here can be the host and can be the VM. If we save the power in the VM, we will definitely save the power in the host. So the target here I want to have is the VM. Because the VM can be used for a lot of usage, like we can using it as a personal computer, or using it like Docker or something else. And so if we define the same policy for all targets, all VMs, that will definitely work well for some of the VM, but it may not probably work for some other VMs. So what I want to do here is to do some classification to make sure we can have a clear definition of the VM. The first VM type I want to introduce is I call exclusive VM. For this kind of VM, I will make one example, which is your personal computer. I don't want to share my personal computer because the personal computer will have some private information. And also the operation of other user may change the interface or change the data or change the status in my personal computer. So if the VM is used as this purpose, so I will suggest that it will be exclusive VM. So the other kind of VM is the shared VM. To make an example, that is remember we have the projector or the printer. A variety of users can provide a variety of information to these two tools that will not have impact to other users. Remember the last presenter using the same project I have, and when I use it, it's the same. They don't have any change when I use it. So if the VM using like this purpose, it should be a shared VM. Another example should be the Docker container, and maybe the web service that provide service for clients. If the VM are used for this kind of purpose, then I think it should be a shared VM. So we have definition of our target to have, which is the shared and exclusive VM. And beside of the target, we will have a look at the condition we need to have to consider. The condition I think we need to consider to take the power management policy. The first is interaction with the VM. If the current user have a lot of interaction VM, so then the VM shouldn't be the target to save the power. So if the VM have no interaction, like no mouse click, no keyboard clicks, or no other device interact, then I think it should be idle or something like not in use. It may be the target to save the power. And even more, we can think about the resource usage in the VM. If the VM have no memory dynamic change, or no I/O, disk I/O, or network I/O, and for this kind of VM, it will have higher possibility that is not in use, that is an idle VM or something. And even more, we can think about the time zone. Think about we are working in the US time zone, and we are in our business time. But currently, the China people or the UK people may not in the business time zone. So if the VM is dedicated for the China or Chinese user to use, then the VM can be shut down or can be suspended when it's business time of the US, right? So that is time zone we need to consider. The last part of the condition, that is the working load, which may possibly be used in a shared VM. Because the working load here I want to define as the whole clients, or the whole number of the clients which is currently connected to our system, which means maybe we have 1,000 of the customer which is connected to our system concurrently, then the working load here will be 1,000. So that is a condition we have to see if we can take the power management policy. So what we need to do here is to do the balance, to balance the power saving with the performance. So if sometimes if we're saving too much of the power, we are getting bad performance. To get both saving the power and a better performance, we need to do the balance here. And to do the balance, I suggest we can have two of the policy to define for the different kinds of VMs. So the first type of the policy I want to introduce is which I call a priority-based policy that can be used for the exclusive VM. Like the picture here, I want to separate the VM for 4 parts. That is and the action can be used for different parts of the VM. Like the green part, that the VM maybe have high use. The high use here may be the high use of interaction or high use of the resources. And it also have a lot of interaction with the current system. And also it is in our currently business network. Then for this kind of VM, I think it will be possibly in use, and it will not be the target to save the power. So I mark it as green, and the action to take the power saving policy should be low. And another kind of VM that I mark as red, that is have low use or low interaction, and also it is not in the business network. For this kind of VM, I think it has higher possibility that is had no use, not being used, or no user was currently using this kind of VM. So for this kind of VM, we can shut down them to save the power. To do things even better, VM can suspend the VM, so we will not lose the status when the VM is running. And that is the higher action we can do to save the power. That is the VM part we can save in the power. And there is another kind of VM that I mark as yellow that is different from the higher and lower policy. And I will using the medium type of policy. The VM will also have the high use of interaction, but it will not in the business network. Or the VM will in the local business network, but it has low usage and low interaction. So for those kind of VM, it will have a medium action to take to save the power. So what is the medium action to take to save the power? What I want to use is to downgrade the priority of the VM to allocating the resource, which means for this kind of VM, we can blooming out all the memories, which is not needed, maybe free. And also we can setting the bandwidth of and the I/O rate of the current VM to a low rate, so it will balance the working load, and it will give the resources to the busy one again. So the busy one will definitely get better performance with the sacrifice of the medium type of the VM. So that is the action we need to do to save the power for the exclusive VM. So besides the exclusive VM, remember we still have the shared VM type. And for the shared VM type, it's quite easy to save the power because it's also almost the same. To calculate the VM quantity or to save the power for the shared VM, there is a formula here, which is quite simple. The working load here is quite the same as I defined in the condition slides. And the catch here, which is to handle the bumping up service, which is required in the system. And the VM capability is how many working load can be taken for each of the VM. So when we adding the working load with the cache and divide by the VM capacity, and we have the VM quantity. The VM quantity here is really what's the size of the VM, what's the number of the VM we are need to running in the XenServer. So it's quite easy to get the result. If we get the VM quantity, we can dynamically change the running VM size to save the power or to start the VM for future requirement. So it's quite easy here. But I want to say the most hard part for this formula is the catch. If we define a quite easy catch for this formula, we will have the VM quantity quite easy. But with the VM quantity, we will dynamically change the working set of the VM, which means we need to start some of the VM if the current working set is smaller than the quantity we require, and shutting down the VM if the current working set is bigger than the VM quantity. And if the requirement of the system change a lot, we will definitely cause a lot of startup and a shutdown of the VM. That is not good, because shutting down or even startup of the VM will causing a lot of power use. So to define a better cache, we need to define a cache to increase and also define a cache for decrease, which means we will have two limitations of cache for the increase purpose and the decrease purpose. So with this formula use, I think we can have a reasonable number of VMs that can be running in the whole system. Sorry. And with the two solutions we have, what my suggestion is what we can deploy this section to. So I think what we need here is the condition. It is what is the input we need for the solution. So we need the interaction of the VM. We need the usage of the VM, the time zone of the VM, and also the working load of the VM. So where can we get this kind of information? Working load balance already provide technologies to collecting such information. So it's quite easy to deploy such power saving policy in working load balance. So, and also working load balance do not have all this ability, like they don't have the interaction to collect. So we still need to do something in the BV driver or something else to collecting the interaction with the VM, so we can get better result. So I think with these two policy deployed in the WB part, then we can better saving the power and provide even better performance of the busy VM. And that is my proposal to saving the power. And thank you. Do you have any question? Okay, cool. So I'm done. Thank you.